I'm hoping we can gamify it today and make it fun. Real quick, before we jump into the problem, I want to share something important about math in general. A lot of students have asked me, why am I even learning this? I'm never going to use it. And honestly, you're not wrong. I've had subjects where I've asked exactly the same thing. And in a sense, you're totally right. I mean, 99% of people aren't solving calculus problems in their daily life. But here's the thing. The real value in math isn't just the numbers, it's that it teaches you how to think. Math helps you to build a structured, step-by-step approach to solving any kind of problem. And that skill, that will serve you well, no matter what career you pursue or where life takes you. So I hope you'll stick around and give math another chance. We'll look for the structure, break things down together, and maybe even have a little fun along the way. Speaking of which, one of the first things we'll do in this problem is play a quick matching game. Then we'll use that to find a clear structured path to the final solution. All right, let's dive into today's problem. So step one is to read the whole problem. Okay, let's break this down. So the second step is to identify the givens and the unknowns. So let's start by highlighting the first given rather. We have 2022, the population is 55,000, right? So let's draw our attention to the middle center here. We'll start filling out a table with our givens and our unknowns. So that will help to guide us through the problem. So who can find the second given? That's right. We have in 2024, population increased to 76,000. Okay. And our unknown, predict the population in 2028. So we'll soon use this table to guide us through the problem. But let's shift gears for a moment and focus on the phrase increases at a constant rate. Okay, let's first take a look at these two graphs and which one represents constant growth. I'll give you a hint. You can look around the game board for a clue. Did you find it? That's right. The clue is y equals mx plus b, the slope-intercept form of a line. And that's how we represent constant growth. Now, which graph is linear? Because that's the one we want. Okay. That's right. The linear graph is graph A. Linear growth is exactly what we're working with here. Now, to complete our matching game, we also have to use our x. So let's x out that second graph. That's not linear growth. And because we know the population is increasing, our m will be positive in this problem. Okay. So next we'll want to complete our givens and unknowns table. But before we fill it in, you might be asking, what is t? And how do we find that? To help us with that, let's take a look at the timeline at the bottom left. So technically, we could use the years directly, like 2022, 2024, and 2028, but the math will get a bit messy. So here's a cool trick. Let's call 2022 the beginning of time. So that means t equals 0 for 2022. And if you're watching this in the future and you were born in 2022, then it is the beginning of time for you. So happy birthday to you. Now, what would t be for 2024? Well, 2024 is 2 years later than 2022, right? So if we're thinking in terms of t's, 2 years later from 0 would be 2, right? Can you figure out the rest? 2 years later is 4. And then 2 years after that is 6. Okay. Now that we simplify the problem by using small values for t, let's finish filling out our table. This will help us to get everything organized. Okay, so what was 2022? What is the corresponding t? All we have to do is now is fill in. We have 0. 2024 was t equals 2 years. And 2028 was 6, right? And of course, the population in 2028 is what we're trying to find, right? Okay. Now, let's shift gears. We know this is a linear equation, but in this type of problem, we're dealing with functions. So let's express that linear equation in function form. The generic form for a linear function with constant growth is p of t slope m times t plus b, right? So this is our starting point. Our goal now is to find m and b using the information from the table above. Our t values and population values that we filled in above, right? So what is m? Recall that a function is like a machine. For each input t, we get a corresponding output p. So let's start by calculating m. That's going to be, for a function, the change in output. Let's write this a little neater here. Change in output divided by change in input. What is the output of the function? If we input a year, the function will tell us what the population is in that year, right? So output is population, and change in output is P2 minus P1. And then change in input is going to be T2 minus T1. In other words, for constant growth, the slope is the rate of change or change in population over time. So we can choose either actually, but for each of these we can choose either P or either T. Let's label these as 1 and 2. So we can start with T1 and T2 as shown there, and then label our corresponding P1 and P2 in the table for clarity. And now all we have to do is plug in and solve. So P2 is 76,000 minus P1, or 55,000, all divided by t2, which is 2, minus t1, which is 0. And what is that equal to? Well, the top is going to be equal to 21,000. 2 minus 0 is 2. And what is the final value for m? 10,500. Go ahead and pause and check my math if you need to. But now we can fill in, for a small win, the value we calculated for m. Just 10,500. So now what? Well, now what's left is to find b. So let's erase and make room for some new calculations. You need room to calculate b, right? And maybe since we already found m, we can erase our question mark for m there too, right? So b, what is that? Well, now that we have m, we can plug into our original function. So let's copy our original function down here first. The generic version was pt equals mt plus b, right? So we know t's and b's, right? So we have m, we can plug that in. If we're able to also plug in a p and a t, our only unknown left in that equation is going to be b, right? And then we can solve for b. We can use either of those t and p combinations from our table, either 0 and 55,000 or 2 and 76,000. But if we choose 0, our calculations are going to be much simpler. So happy birthday to all of us. Let's see what that looks like. So P1 times M, which is 10,500, times T1 is B, right? So we just plugged in M. Now let's plug in our chosen P1 of 55,000. That's equal to 10,500 times what's T1? Our happy birthday value of 0 plus B. So that looks like something we can solve for B, right? And here's our big birthday win. 0 times whatever is 0. And now we have a really easy equation, right? 55,000. Oops, let's make it a little prettier. Equals B. So now we get another small win and fill in B into our table, which is 55,000. So now we have everything we need. So now we can create our final population growth function that is specific to this problem just by plugging in M and B that we just calculated. So the final function for population is plug in M, 10,500, times T, plus our very special B, which is 55,000. All right, so now that we have the function, we can use it to predict the population for any future year. And of course, we'll choose 2028, right? Or T equals 6, because that was the whole point of this problem, right? We're trying to predict the population in 2028. All right, let's make some room. So we're going to have just one more little calculation left to reach finish line. And then to predict at t = 6 the population, all we have to do is plug in p of t equals p of 6 in this case, which is equal to 10,500 times, you guessed it, 6 plus b, which is 55,000, right? Okay, what's that all equal to? Pause and do the math if you need to, but this is going to come out to 63,000 plus 55,000, which is 118,000 people in 2028 in this small town. And there you have it. We used a linear function to predict the population in 2028. It's all about breaking down the problem step by step. Now you know how to solve problems just like this one using linear functions. So if you enjoyed this breakdown, be sure to like the video and share it with anyone else who might find it helpful. Drop a comment below and share your triumph with others. Or if you have any questions about today's problem, feel free to ask those in the comments as well. And of course, don't forget to subscribe for more algebra tips and problem-solving strategies. You can also support the channel by checking out the links below. And thank you for watching, and I'll see you real soon in the next one.